Imagine discovering that the biggest event in cosmic history never happened. For decades, the Big Bang has been treated as the unquestioned birth of everything: space, time, matter, energy, and even the laws of physics themselves. It is the foundation of modern cosmology, taught in textbooks, echoed in documentaries, and accepted almost as cosmic fact. But what if this story is incomplete? What if the universe did not explode into existence from a single beginning at all? Welcome to Information World. Let's start by understanding what the Big Bang actually claims and what it does not explain. The Big Bang theory does not describe an explosion in space. Instead, it describes the expansion of space itself from an extremely hot, dense state. Galaxies are not flying away from a central point, rather, space between everything is stretching. When scientists look back in time by observing distant galaxies, they see the universe becoming hotter, denser, and more compact. This idea is supported by several powerful observations. The first is the redshift of galaxies. The farther away a galaxy is, the faster it appears to be moving away from us. This relationship suggests a universe that is expanding uniformly. The second is the cosmic microwave background radiation, a faint glow filling all of space, often described as the afterglow of the early universe. The third is the abundance of light elements like hydrogen and helium, which match predictions from a hot early universe. On the surface, the case looks strong. But science does not end with surface explanations. When researchers push the Big Bang model to its limits, serious questions appear, questions that do not yet have satisfying answers. One of the biggest problems is the idea of a singularity. According to classical physics, if we rewind the expansion far enough, the universe reaches a point of infinite density and infinite temperature. At this point, known as the singularity, the laws of physics break down completely. Gravity becomes infinite, time loses meaning, and equations stop working. In science, infinities are not explanations, they are warning signs that a theory is incomplete. If the Big Bang truly began from a singularity, then science cannot describe the actual beginning of the universe. There is no equation that explains what caused it, what existed before it, or why it happened at all. This raises a disturbing possibility: maybe the Big Bang is not the beginning, maybe it is just the earliest moment we can currently see. Another major issue is the horizon problem. When scientists observe the cosmic microwave background, they find that distant regions of the universe have nearly the same temperature and structure, even though they should not have had enough time to exchange information or energy. In simple terms, parts of the universe that were never in contact somehow look perfectly synchronized. To fix this, physicists introduced cosmic inflation, a rapid, exponential expansion that occurred just after the Big Bang. Inflation helps solve several problems, but it introduces new ones. The mechanism behind inflation is still unknown. The energy field responsible for it has never been directly observed. Worse, inflation can lead to infinite universes and countless variations of physical laws, making it difficult, sometimes impossible, to test experimentally. Some critics argue that inflation is not a prediction of the Big Bang model, but a patch added to save it. Then there is the flatness problem. The universe appears to be geometrically very close to flat, meaning its total energy density is finely balanced. For this to happen naturally after a Big Bang, the initial conditions must have been tuned with extreme precision. Even a tiny deviation in the early universe would have resulted in a cosmos that either collapsed quickly or expanded too fast for galaxies to form. This level of fine-tuning raises uncomfortable philosophical questions. Is it coincidence, necessity, or something deeper? Now let's ask the forbidden question: what if the Big Bang never happened at all? One alternative idea is that the universe is eternal with no beginning and no end. In this view, the universe has always existed in some form, evolving through cycles or phases rather than originating from a single creation event. This concept may sound radical, but it has deep roots in both ancient philosophy and modern physics. The steady-state theory, once a major competitor to the Big Bang, proposed that the universe is expanding but maintains a constant density through the continuous creation of matter. While this model fell out of favor due to observational evidence, it introduced an important idea: expansion does not necessarily imply a beginning. More modern eternal universe models go much further. Some suggest that time itself extends infinitely into the past. Others propose that what we call the Big Bang was actually a transition, a phase change rather than a birth. Similar to how water can change into ice or vapor, the universe may have shifted from one state to another without coming into existence from nothing. Another powerful alternative is the bouncing universe model. In this scenario, the universe undergoes endless cycles of contraction and expansion. Instead of beginning with a Big Bang, each expansion follows a previous collapse, a big crunch, which then rebounds due to quantum effects or unknown physics. The bang we observe could simply be the latest bounce in an infinite cosmic heartbeat. Bouncing models solve several problems at once. They avoid singularities by replacing infinite density with a minimum size. They eliminate the need for a beginning of time. And they can naturally explain the large-scale uniformity of the universe. However, these models require physics beyond our current understanding, especially in the realm of quantum gravity. Then there is the idea that the universe emerged from a quantum fluctuation, not from nothing, but from a deeper quantum reality. In quantum physics, empty space is not truly empty. It seethes with virtual particles popping in and out of existence. Some cosmologists suggest that our universe could have formed as a quantum event within a timeless background, without a classical beginning. This leads us to a profound realization: the word nothing may be meaningless in fundamental physics. What we call nothing might actually be a highly structured, energetic vacuum governed by laws we barely understand. If so, the Big Bang may not be a creation event, but a reorganization of pre-existing reality. Another radical idea comes from loop quantum cosmology. In this framework, space and time are not continuous but made of tiny discrete units. When these quantum properties are applied to the early universe, the singularity disappears. Instead of a Big Bang, the universe transitions smoothly from a contracting phase to an expanding one. Once again, no beginning, only change. String theory offers yet another possibility. According to some versions, our universe could be a three-dimensional brain floating in a higher dimensional space. The Big Bang might have occurred when two such brains collided. If true, our universe's origin lies not in time zero, but in interactions within a larger cosmic structure that may be eternal. These ideas force us to confront a deeper question: is time itself fundamental, or emergent? If time emerged with the universe, then asking what came before the Big Bang may be meaningless. But if time exists independently, then the universe could have a history far older than we imagine. Some physicists argue that time is not a universal flow but a local phenomenon tied to entropy and observation. In this view, the universe could exist in a timeless state, with the Big Bang representing the moment time became meaningful for us. That would mean the universe did not begin, our experience of time did. Observationally, there are hints that something strange may be happening. Recent measurements of the expansion rate of the universe show inconsistencies depending on how and where we measure it. Known as the Hubble tension, this discrepancy suggests that our understanding of cosmic history may be missing something fundamental. There are also anomalies in the cosmic microwave background, unexpected cold spots, alignments, and asymmetries that do not fit neatly into the standard Big Bang model. While none of these anomalies alone overthrow the theory, together they whisper that the story may be more complex. If the Big Bang never happened, the implications are staggering. Creation would no longer be a single event, but an ongoing process. The universe would not have a birthday. The question "why is there something rather than nothing" would be replaced with "why does existence persist at all?" Philosophically, this shifts our understanding of reality. A universe without a beginning challenges traditional notions of causality. It suggests that existence may be self-sustaining, requiring no external trigger. This does not eliminate mystery, it deepens it. It also changes humanity's place in the cosmos. If the universe is eternal, then civilizations could have risen and fallen countless times before us. The observable universe would be only a small window into a much larger, older reality. What we see may not be the whole story, just the part accessible to our instruments and our era. Importantly, rejecting the Big Bang does not mean rejecting science. Science thrives on questioning its own foundations. Many of history's greatest breakthroughs came from challenging ideas that once seemed untouchable. The Big Bang may still be correct, but it may also be incomplete. Right now, cosmology stands at a crossroads. We have powerful observations, but incomplete theories. We have elegant equations, but unanswered questions. Whether the universe began with a bang, a bounce, a transition, or something we have not yet imagined, one thing is clear: reality is far stranger and richer than any single model can capture. And perhaps that is the most important lesson. The universe does not owe us simple explanations. It invites curiosity, humility, and awe. Every answer leads to deeper questions. Every discovery opens new mysteries. If the Big Bang never happened, then existence is not a story with a first page, it is an endless book, and we have just learned how to read a few lines. Thank you for exploring this cosmic mystery with me. If you enjoyed this journey through the deepest questions of existence, don't forget to like and subscribe. It truly helps the channel grow, and more mind-bending stories are coming soon.